Imagine stepping onto an airplane and noticing something unusual the moment you look out the window or glance at the tail. Not 2 engines, not 4 engines, but 3, one on each wing and one nestled into the tail, fed by a curved intake duct. It looks a bit strange, almost futuristic, even today. But for several decades, this unusual layout wasn't rare at all. It was cutting edge. It was the future, and dominated some of the world's busiest air routes. These were the Trijets, 3-engine aircraft that once promised the perfect balance of efficiency, range, reliability, and performance. They became icons of the jet age, flown by airlines all over the world, and beloved by pilots and passengers alike. Yet today, Trijets have almost entirely disappeared from commercial aviation. So what happened? Why did these remarkable machines fade away? And what made them such a big deal when they first arrived? In this video, we're going to dive deep into the full story, the rise, the triumph, and the eventual fall of the Trijet. We'll explore how they emerged during one of aviation's most exciting eras, the engineering innovations that made them possible, the legendary aircraft that defined the category, and the economic and regulatory changes that ultimately doomed them. Let's rewind to the beginning. The story of the Trijet begins in the 1960s, a decade often called the golden age of commercial aviation. Air travel was expanding rapidly. Jet engines were improving at an extraordinary pace. Passenger demand was booming, and airlines were searching, not just for any airplane, but for airplanes that could open new markets, fly farther, carry more, and operate more efficiently. Back then, aircraft designs had to work around a major limitation: engine reliability. Today's engines are incredibly dependable. Modern twins like the Boeing 777 or Airbus A350 can cross oceans with ease. But in the 1960s, that wasn't the case. Turbofan technology was still new, failures were more common, and regulators were understandably cautious. For safety reasons, twin-engine jets were restricted on long overwater routes. Losing half your engines halfway across the Atlantic just wasn't acceptable. On the other end of the spectrum, 4-engine jets, like the Boeing 707 and Douglas DC-8, offered excellent redundancy, but all those engines made them expensive to operate. More engines meant more maintenance, more fuel burn, more weight, and higher costs. Airlines wanted something in the middle, a long-range capable aircraft that was safer and more efficient than a twin, but cheaper to operate than a quad. The Trijet concept seemed like the perfect compromise. 3 engines, not 2, not 4, just right. This wasn't just a balancing act. It was a clever engineering solution tailored to the era. Trijets offered several attractive advantages that lined up perfectly with the needs of 1960s and 1970s air travel. 1. Improved safety and redundancy. With 3 engines, airlines could confidently fly longer routes without the regulatory restrictions that twins faced. If one engine failed, 2 were still available, more than enough to continue flying safely. And while this may sound basic today, in the early jet age, that level of redundancy was a huge selling point. 2. Strong range and payload performance. A 3rd engine meant more thrust, which meant airlines could carry more passengers and cargo and fly longer distances. The DC-10 and L-1011, for example, could carry over 250 people across the Atlantic, something twin-engine aircraft simply weren't allowed to do at the time. 3. Better airport versatility. Many airports in the 60s and 70s lacked long runways or infrastructure for larger 4-engine aircraft. Trijets, especially the Boeing 727, were designed to operate from smaller fields while still carrying substantial loads. This opened up entirely new routes for airlines. 4. The S-duct, a tail-mounted masterpiece. The defining feature of the Trijet is the tail-mounted center engine. Feeding air to this engine was a challenge, and the solution was the S-duct, a curved intake that snaked through the tail. It was an aerodynamic and engineering marvel for its time. On the Lockheed L-1011 TriStar, the S-duct was especially elegant, creating smooth airflow, reducing drag, and even reducing cabin noise. The clean wing, free from the central engine, improved lift and efficiency. Overall, Trijets checked a lot of boxes. They were safe, efficient, capable, and versatile. It's no wonder they became the backbone of many airlines. First flown in 1963, the Boeing 727 was a runaway success. It was designed specifically for domestic U.S. service and could operate from shorter runways thanks to its 3-engine configuration, advanced high-lift devices, and impressive takeoff and landing performance. Airlines loved it because it allowed them to expand their networks without expensive airport upgrades. With 1,832 aircraft built, it became one of the most successful jetliners ever produced. Entering service in 1971, the DC-10 was the international long-haul trijet. It could carry more than 270 passengers, making it ideal for intercontinental travel. It was also extremely versatile, used by both airlines and cargo carriers around the world. However, the DC-10 had a troubled start. The infamous Turkish Airlines Flight 981 crash in 1974, caused by a cargo door failure, severely damaged its reputation. After extensive redesign and improvements, the aircraft became reliable, but the early setbacks followed it for years. Often considered ahead of its time, the L-1011 TriStar featured a state-of-the-art autopilot, advanced engine control systems, Rolls-Royce RB211, 3-spool engines, and an exceptionally quiet and comfortable cabin. Only about 250 TriStars were built, mostly due to financial issues that disrupted production, but among pilots and engineers, the L-1011 is remembered as one of the best-designed airliners ever flown. By the mid-70s and through the 80s, Trijets were everywhere. They became the perfect middle aircraft, ideal for routes that were too long for early twin-engine jets and too thin for 4-engine giants. In the US, the 727 became the backbone of domestic travel. Internationally, the DC-10 and TriStar carried millions of passengers across the Atlantic, Pacific, and everywhere in between. For about 20 years, the trijet reigned supreme, but aviation never stands still, and the forces that made Trijets successful were about to shift dramatically. These are the three major developments: technological, regulatory, and economic, combined that made Trijets obsolete. 1. Engine reliability improved dramatically. By the late 1980s and 1990s, jet engines became vastly more reliable. This changed everything. The introduction of ETOPS, extended twin-engine operations, allowed twin-engine aircraft to fly long or overwater routes that were previously restricted. ETOPS regulations essentially said, twins are now reliable enough to do the job of 3- and 4-engine aircraft. And this was a death sentence for Trijets. Their main selling point, superior redundancy, no longer mattered. 2. Twin-engine jets became more efficient and cheaper. A third engine adds weight, drag, fuel consumption, extra maintenance, extra parts, and extra inspections. Airlines realized that modern twin-engine wide-bodies like the Boeing 767, 777, and Airbus A330 could do everything Trijets could, but cheaper. Fuel prices rose in the 1990s, and suddenly every extra pound of fuel burn mattered. Operating 3 engines simply didn't make sense anymore. 3. Maintenance logistics became a major cost. The tail-mounted engine created unique challenges. Servicing it often required special equipment and longer turnaround times. With twins, all engines are mounted under the wings, easy to reach, easy to inspect, easy to replace. In a low-margin industry like aviation, simplicity wins. 4. Passenger expectations evolved later. Wide bodies offered larger cabins, quieter engines, better ventilation and air conditioning, and more cargo capacity. Compared to the growing comfort of twin-engine jets, Trijets felt increasingly outdated. By the 2000s, airlines had all but abandoned three-engine designs. Even though trijets are gone, their technological innovations left a permanent mark on aviation. While modern jets don't use S-ducts, the airflow research behind them informed advancements in engine nacelle design and aerodynamic efficiency. The Rolls-Royce RB211 from the TriStar became the foundation for later engines powering the Boeing 747, 757, 767, and 777. Its influence continues to this day. The TriStar's autopilot was one of the most advanced of its time, paving the way for more sophisticated automated systems on modern aircraft. Trijets helped airlines understand how to optimize long-range route planning, crew operations, fuel management, and maintenance scheduling. They were a bridge between early jets and the highly sophisticated wide-body aircraft we rely on today. By the 2000s, trijets were mostly relegated to cargo operations. FedEx and UPS used DC-10s and MD-11s well into the 2010s and 2020s. Passenger trijets disappeared earlier. The last commercial passenger trijet flight occurred in the mid-2010s, marking the end of a remarkable era. Today, you can still find trijets in aviation museums, cargo fleets, and military service like KC-10 tankers, for example. But in passenger service, the trijet is now a relic of the past. Ask any aviation enthusiast and they'll tell you, trijets have a special aura. Maybe it's the distinctive silhouette, maybe it's the unique sound, maybe it's the role they played in shaping modern flying. The 727 opened up air travel to smaller airports. The DC-10 transformed long-distance flying. The TriStar pushed engineering boundaries that were decades ahead of their time. Trijets weren't just aircraft. They were symbols of innovation, ambition, and the excitement of an era when air travel was still new and full of wonder. The trijet was never a failure. It was a bridge technology, a stepping stone that carried aviation from the early jet age into the modern era. It solved the problems of its time brilliantly. It opened new routes, connected new cities, and pushed engineering limits. And even though it eventually became obsolete, its legacy lives on in the aircraft we fly today. The story of the trijet reminds us that aviation is constantly evolving. Designs come and go, technologies rise and fall, but every generation of aircraft moves us forward.